So we are here working with the file 05car, and I have created one for myself and started a pull request on a branch that has the exact same name as the file. And I have already done tasks that we are already familiar with, which is importing the data. And now we are going to basically start transforming the data in a meaningful way. But the one thing I wanted to show is that this report is parameterized, and therefore there is now a params object available in my environment. And if you do not remember, let's have a look now. Here at the very top, the YAML header has a params field, and it itself has another field called year, and the year is set now to the values 1952 and 2007, and there is a couple of specifications that are the ones that I need to create this interface when you need with parameters. So this is the params. Where is my? There you go. So the params object here is the one that I want to access now in this line here. So I want to see what the contents are. So we already saw it at the top. It's 1952 and 2007. So this is just to remember what that was, and now we can use it, right? So those parameters now are available in this document to start, for example, filtering the data, so that in this case what we're going to do is, okay, let's get the minimum value of this vector, which is 1952. It is 1952 now because it's kind of hard-coded on the params, but when the user uses the slider interface, that value will change, and this code will adapt to that change. So what we want to do here is use that params object and say where params year is the minimum, and so it has to be greater or equal than the minimum, and smaller or less than or equal to params year, right? So what we are doing here is filtering basically the data on the range that the user provides. So this line is the one that does the magic of adapting the report to the input of the user. And finally, we want to select the columns. Just we care about the columns. Remember that this tidy data set has a bunch of columns. Some of them I don't care about for this particular analysis. So I'm gonna select only country, year, and life expectancy. So that's all we need for the rest, I think, of the lesson. So let's have a quick look at this data. We're gonna create geom smooth. So geom smooth creates a linear model, and we can specify which method we want. So we want the LM method, the linear model. So geom smooth is the function we're going to apply, and the model that we want to create is that of with year on the x-axis, because it's quite natural to see a time sequence on the x-axis versus life expectancy. And remember, we discussed this group parameter. It's a parameter that you need, especially when you create line plots, to specify which points of data should be considered together. So in this case, what we want to do is to group by country. So we do that geom smooth, and so let me first show you what it could look like if I just stop there. So if I run this code, what you get is each line is a linear model that represents all the data points for a particular country, but it is quite messy because the lines are a bit too thick, and also because there is those shaded areas at the background that try to capture the uncertainty of each model. So we can do a little better than that by trying to reduce overplotting a bit. So in this particular case, I don't need the SE, so I don't need the standard error, that shaded gray area. So I can remove that with SE false. And I think you also saw this parameter alpha, which you can set to something like a third. Anything that is less than 1 will reduce the opacity, and you may also use size as a way to make the lines a little thinner. So that way, what we have is just a very kind of rough idea of how the linear models that represent the different countries are what they are doing. So the very big trend you can see is that with time, almost every country has gone up in life expectancy. So for almost every country, things are getting better, except for a few countries which we don't know what they are, but they are there. From just this very course plot, we learned that lesson that most countries have done, have improved through time. A few countries haven't, and we don't still know if those countries, what their countries are, or if the data is trustworthy. Maybe there is a lot of uncertainty there, and maybe that's not a significant trend. But anyway, we can explore that. So let's walk a little bit with modeling. So the first thing we want to do is to acknowledge that there is at least two ways to tackle the problem. What we want to do is, okay, we know that the Geon Smooth from ggplot can create models and can show them, but we haven't yet accessed the parameters of those models. So what if we wanted to find, for example, the 6 countries that have an R² value, so that is the highest, which means which are the 6 countries whose models fit the best the data, and which are the countries that have models for which the fit is the poorest. So we have some issues in the data. We don't have a good model that could be able to predict what's going to happen with those countries, say, in the future, because the fit of that model to the data is poor. So if we want to detect which are those countries in a programmatic way, in this case we have too many countries to look at them one by one, it could get worse, then we need approaches. So the approaches that we're going to visit is the map approach, which is this list style way of doing things, and this is kind of a more general approach. Anything that you can do to a list, you can work in this framework, and it has been in the tidyverse for a while. And the second approach is going to be one working with rowwise, which for many of us, including myself, is pretty new. The tidyverse released an improved version of rowwise and started advertising it only, I think, 3 months ago or so. So the first thing, actually, we are in a tidyverse and we are working with dataframes. So in the tidyverse, what is in the dataframe stays in the dataframe. So the first thing we would want to do is to create a list, but inside the dataframes. How do we go about that? So we group, in this case, by country, and because that's the unit that we want to study through time, and we nest. So it is nice that what that gives us is this data structure that you see here, where each row is just one country, because we have nested all the data for that country. Remember, one country had many rows for the different years, but now we compress them all in a single row, except that there is this list column, this column called data, now contains all other columns, right? The rest of the data is in there, in that column. So each row contains a whole table inside it, right? So now, because it's a list, we can use the approach that we know for lists, which is map. Remember, map helps us work with lists and do something like, for example, apply a linear model to not just one data set, but to, in this case, different data sets. Each data set is in one element of that list column, right? So data is no more and no less than a list. So we're going to use it. But we're going to use it inside mutate, because not only this is a list, but it is also a data frame. So this is where kind of it makes more sense to kind of discuss this idea that a data frame is a list and it can contain a list. But at the same time has some properties that the tidyverse knows about. If it's a data frame, then you can use select, you can use filter, you can use mutate. Those functions you cannot use with a vanilla list. You have to use it with a special list of kind data frame or table. So again, this thing is two things at the same time. It is a list, and thus we can use map, but it is also a data frame, so thus we can use mutate. So we use map inside mutate, and what does map return? It returns another list. That's always the case. Map has frames like map double, map character, and so on and so forth, and those return what the suffix suggests. But map, vanilla map, returns always a list. So the model that we want to create inside the data frame is the model of life expectancy versus year, right? And how you express a a call to lm. So that's something I can learn on the head file of the function lm. But basically, just you can specify with this is one of the ways to specify the relationship that you want to model, the relationship between, in this case, life expectancy and year. And then it has an argument, the function lm has an argument called data, which is a little confusing because we also have a data column, right? And there, what are we going to feed it? Well, we are going to feed that element, right, that comes in each element of the list. So how do you refer to that in map? Well, you refer to that as .x. Remember that this curly here is not the formula one in here, it's a different one. This is just a shortcut for function of .x and everything that follows here. So what you're applying on map is this function here, right? And there is a shortcut for doing that. So we use that shortcut like that. And finally, so let's run that to see what it looks like to begin with. Here we have the data column, and we have a new list column that results from calling map inside mutate that is stored in mod, right? So we have stored this output as a new column called mod, and that all still lives in a data frame. So if you want to see this on the console, let's do just that. Same thing, this is what it would look like in the console. You have your normal table, you have it's a grouped data frame, and it has two list columns. This column, say is of the type list, and has a bunch of tables, each one of with 12 rows, one per year, and 5 columns. All the columns that the data set you have, and then here we have also one linear model per country. There is a total of 142 countries. So convenient, inside the data frame we have run linear models 142 times just with that call to map. So now we want to extract, say, one parameter, the RSQ parameter, the R square, to know how well, for example, each of those models could represent the data, would fit to the data. So how we can do that? We can do summarise, and we're gonna create a new column inside summarise that is going to contain those RSQ values, and we are going to use a friend of map, doubles, because what we're going to do is we're going to extract the RSQ value, and the RSQ value for each model is just one number. So we can use map double that specializes in the outputs that are not list but just one number. So one number per element. Thus we can use, if the output is one number per element, then we can use map double. If the output was one character string per element, then we could use map character, and so on with integers, and I think we run out of options there. So in this case, what we are mapping, actually I think we could start with the vanilla map. What we are mapping is, again, remember, this is a shortcut for a function of .x, the summary of each element on that list. First calculate that, so the function summary given a linear model will create an object, right, that contains a bunch of parameters, and from all those parameters what we want in this case is the R square. So that's one of the parameters that exist in the output of summary. And how we extract that? We can extract that, for example, with the $sign notation. And because we know better than typing all of this, we can use that little shortcut, and that is what brings us to something closer to that. So I'm going to run this code. Actually, this is a bit adventurous. I'm going to run it with map. So what I expect is to get a list, because map specializes in lists. So let's see if that works. It does, right? So it's a list, and it contains a double of length 1. I know a map function that deals with doubles of length 1. Which one is it? It is map double. So by doing so, I get a nicer output. What I get is that double that was wrapped in a list now boom comes out of the list and is exposed directly as a column in the data frame. So we have just solved a problem with group by and nest, created a nested data frame with a list column data, and used that list column to map a linear model to each of those countries. Then we summarized with the function summary to extract the R² value. So let's do something now a different way. So in this other approach, in the rowwise approach, kind of looks similar, but it's not quite. So we start with the same data set, right? And now, instead of doing group by and then nest, we just nest by. This will create a data structure that has a very small but important difference, which is also a nested data frame. As you can see, the data column is still a list column, as with the framework group by plus nest, but this is row-wise, meaning that any operation that we do, the operations won't work like that along the columns. They will work across the columns, row-wise, right? So with that subtle but crucial difference, let's go back to the code. So the first thing we actually, I think where do I have my? That's gonna be a challenge. Map approach and rowwise approach. It looks like I deleted for myself the instructions. Let's see if I remember. So the first thing I would like to do is to create that mod column, right? So first I create the models. So actually let's type it here. Create the models into the new mod column, and that is a list column, right? So that's my first step. That's gonna be It's gonna be LM, right, of life expectancy versus year, and the data is gonna come directly from, let's print this, it's gonna come directly from here. So when we nested by country, what we got is this list column. So now in this framework, because it's row-wise, it's not going to look at the at this element as a list element. It's going to look inside that list element and get the element itself. So we can refer to it as data right away, and we don't need to use map, because again, map work with lists, but this approach, the row-wise approach, will look into the element. So we can just think that what this will be fed is directly the data that comes from data. It doesn't know that there is more rows piled one on top of the other. For once we are working with row-wise inside mutate, it will think that it is performing an LM directly on the element inside the data. So that is kind of cleaner in that we don't need to call map, and we are not dealing with that complexity. Map also brings some complexity. The one thing that we need to remember is that we need to wrap that in list, because we need to create a list column ourselves. So the output of that should be kind of similar to what we got before after we ran mutate, where we do have this new list column mod, and now we are going to use that list column in a call to summarize. So now we are going to get inside mod, right, inside mod here, and what we're going to call is the function summary, and then to call summary inside summarise. Tricky, summary inside summarise. What it does is takes those models inside the mod column, that each of those models, and then applies the function summary, and then that will return a bunch of parameters, and from all of those we are in this case we chose to get just the R². So we do square brackets, dollar signs R². So same different approach, same result, right? So we have here our column of countries and our column of R². So this is where last lesson I mentioned, well, maybe the row-wise approach doesn't add anything to the problem that we solved in previous lesson, because we could have done it differently with first by tidying the dataset. But then in this case, it is pretty elegant. See how the code has a couple of less lines, and we don't need the map mental model, how map works. It just call the function as they are, like right away. And this only complexity is you know, that we have to wrap that in list to create the list column. So you just need to understand that, you know, whenever, you know, the data structure is complex, data frames cannot deal with it in a direct way. You have to wrap it in list, and then the list is something that the data frame can store, because you know, the list will contain any number of elements, but the list itself is one thing, one element. Okay, so now let's do something with those R² values. So what we would like to do is, okay, use that information to find in the original data set the countries that have the best and the worst fit to the model, or the models that fit best or worst to the data, to say it correctly. So we start with the R² data set that we created. We have countries and we have R². Our job now is to arrange, well, first we need to ungroup this thing, and I'm going to show that after we run this, why we need to ungroup. So far R², see this in the console, R² is a rowwise, or is it not? No, because I'm working with rowwise. I think the one that is rowwise is R²2, right? R²2. Yes, so R²2. So let's use that one just to add some pain that we need to then fix. So rowwise 2, we need to ungroup it because it has that group structure that could get in the way. What we want to do now is to arrange things across, so that in the vertical direction, and this R²2 is grouped rowwise. So that means that we won't be able to arrange it, because it will consider each row independently. Whatever, if we now are gonna arrange rows here, what we're gonna do is call arrange with the helper function descending to get values of the column R². So this R² is this one here. So we want to arrange so that the values of R² are descending, with the highest at the top and the lowest at the bottom. But what would happen if we do not ungroup? If we do that, then when we run our arranging, the arranging is gonna, the scope of arrange could be each row in itself. So it's trying to arrange a data frame of one element, right? So overall, it is not accomplishing what we want. As you can see, I have run that arrange where we here. Actually, this is the output. If I run these couple of lines, actually, it seems to have worked. Maybe it's not behaving the way I thought. Okay, surprising. And what happens if I do it? Maybe I'm confused about which. Anyway, well, probably I'm kind of tripping with myself. So I'm gonna go back to just going for it and then finding my broken mental model here. I was, looking for odd representation or arrangements here based on the grouping, maybe because I didn't run this before. Let's see, R2, and let's ungroup. So curious to see what's going on here. I wanted to demonstrate that if we didn't ungroup, this won't work as we expected, but it seems that it is. So there is something there that I don't understand, and it's not going to be now the time to fix it. So, okay, we'll leave it just for now there. So what we have achieved now, we just in case we are grouping that won't ever hurt, and we are arranging rows, and we have achieved arranging this in descending order. The country at the top is the country with the best fit, where the model fits best the data, and so on and so forth. So then decreasing in that along the length of the column R². So the next thing we're going to do is to have a look at that. Remember, we discussed the idea of functions that are called for their side effect, but then they pass their input along to other functions. So one of those functions is print. So, while we do this pipeline, we can copy print in the middle to see what's the output at this point. At this point, what we have, so what we can explore interactively here on the console, but when we render the report, I would like this, at this point, I would like to see what we are seeing now here on the console. Because right now, right after that, we're going to pull the column country, meaning that this column will become a vector, right? So once I do that, what I get is a vector. So here you see I extracted the countries from inside the data frame, but the data frame before has been arranged by order of R square, meaning that if I do, for example, the head of the resulting vector, what I get is the first countries that were the ones that were matching the highest R square. So that means those are the countries with the highest R square. And if I did the tail of that, what I would get there is the countries with the lowest R square. So the countries where the model fit very poorly the data, right? So let's leave it there. And with that, so now that we have that variable countries, that is the country names, but in a very specific order, in an order that tells us something about how good or how bad is the fit of the model to the data, then we can use it to filter the picked dataset, so the dataset that the user filtered through the slider. We're going to now filter it further to get just the countries that show either the highest R squares or the lowest R squares. That's just one exercise that I want to do to show basically if the results that we are getting from the models that we computed ourselves are similar to the models that we get when we plotted like the linear models with ggplot2. So let's check that, because what it means is that if our our computations are correct, what we could expect is that when we plot the countries that we found have a very high number of R squared, then we could fit that the smooth linear model in ggplot2 should produce a line that really adjusts with a very thin uncertainty. And when we plot the countries that have a very low level of R squared, we would expect that ggplot2 would plot those with a very big uncertainty level. So let's try that. So here what we are going to do is we're going to filter the picked dataset that we're working with. And here what we want is to get just the first few countries from the vector countries and the last few countries from the vector countries. So with that, what I get is, with head and tail, what I get is a little vector that contains the 6 countries with highest fit and the 6 countries with lowest fit. So we run that, and what we get is it is a data frame now, because filter works on the big data frame, and it excludes everything except those columns that meet this condition. So I'm looking for country in the vector, head countries concatenated with tail countries, right? So this data frame has, in this case, only 144 rows, and it should have the countries that we found in the head and tail of the vector countries. So let's do now a little plotting to see what things are looking like. So in this case, and because we are approaching the end, also we're getting more complex, not just in analyzing data, but also in abstracting our analysis in functions in this case. So what we are going to do is, we are going to write a ggplot, as you already know, using the template, the geom and some AES, and then one layer, in this case, the geom smooth. The geom is going to have the method lm, and then we're going to facet the plot by country, and then at the end we are going to change the theme, so the styling of the plot, so that it looks black and white. But all of that we can abstract. So if that's a plot that we can reuse many times, then why not stick it inside a function. So in this case, the only thing I did is, once I wrote the skeleton of the plot, I just, call the main argument data, generic, and then created a little function that has the argument data as the main and only argument. So that function is a little helper function that we could use if we wanted to plot, for example, our data high-low. So our data high-low is the one that we had just filtered, that contains countries with highest and lowest R squared. And now, we can pipe that into our function makeplot and thus get the plot that we expected. So this way, we see a bunch of countries, and we see, the fit. We see some lines that are just very tightly, and we almost see no uncertainty there because the models fit so well. And then we see other countries that they have a wider shaded area. That means that they are the ones with the low R squared values. And it looks like the distribution of the panels in the plot is not following the order of the vector that we chose. It is following just like an alphabetical order. But that's fine. So what we want to do now is, so what if we wanted to create a plot in our disk, if we wanted to save each of these panels individually as a plot? That's an iteration problem. We want to iterate over each element of the column country, create the plot that we abstracted with the function map makeplot, and so get each country, apply makeplot, and then save it into a file in the disk. And the file could have a name that comes from the name of the country itself. It could make sense to have like a CSV file in a folder called, say, output, that is called Brazil.csv. .png, to show the image that you're seeing here, but without the rest of the country, right? Each country in its own PNG file. How do we go about that? I mean, you could save, in RStudio, you do have an interface to save like a plot. Not this one here. So if I show you all panels, there you go. So once you have created a plot in your viewer, you will have options to export it to a PNG or PDF, or I think that's just or JPEG. That's about it. But what we're going to do is to save it programmatically, also to show off one other feature that we haven't covered of ggplot2, which is ggsave. So let's overview what we are about to do. So we have this high-low data set that contains countries, contains years and life expectancy. So the first thing we're going to do is we're going to split it by country. So we're going to be using like a list approach, right? So we can use the function split that actually comes from base R. So when I say dot here is the same as saying high, low. So it's that the entire data set that was passed inside split is what I want to split by. Because if you look at the help file of split, the first argument is the data set and the second one is the column of that data set, but not the tidyverse-like way where you just say the name of the column itself. Instead, not like this. Instead, it wants the entire column expressed as high, low, country, right? So if you print this, you do get exactly one each. Basically, you are pulling out the column country from high-low, which actually we could do. Probably we could do pool country, I guess, but this syntax is very compact and very useful. So with this, we create a list of data frames where each data frame contains the data associated to that country, and also contains as a name the name of the country. So let me show you that is important for the point that I'm trying to make. So if we print this to the console, you will see that each data set for each country has a name, and the name is the name of the country associated to it. So as you can see Switzerland, right, is the same country, and so on and so forth. So, but the name is going to be useful because we want that name to create the paths to the files where we are going to save those plots. And here is how. So the first thing we want to do is to map makeplot. So remember, we created a function makeplot, and we already know that with map, if we have a list and a function, we can combine them into a call to map to create one, so to map elements of a list to a function and repeat, right? So instead of using a for loop, in this case, we are using map, iterating over each element of the splitted list by country and mapping that to makeplot. So if we run that, what we do get is that we get one plot in its own. So for each country, we get our own plot. So in this case, let's see, this is for the Botswana, for Brazil. This other one here is France. So each of those independently in one plot. Now the next step is, okay, it would be really cool. So now that we have those plots in a list, it would be really nice to save them all at once into a directory. How do we do that? Okay, we can do that with iwalk. So map has a friend that is called walk. Here, walk, right? And you use walk. Remember, I mentioned the distinction between functions that I called for their side effects versus other functions that I call for their computations. So the function that I call for their side effects, generally you don't want to, they can do their thing silently. So if you're saving a file to the disk, yeah, you don't need to return anything. You just want the side effect. So instead of using map, you use walk. And in this case, we're using a particular flavor of walk, which also is aware of the names of the thing that you are walking over. So it's mapping and walking is kind of the same thing, except that you walk over things that produce side effects and you map over things that produce computations. So like before we were creating a plot, now we're just saving a plot to a file. Again, the side effect of saving a file. So internally, iwalk works like this. So it is looking into an object, an element of the list, and the name of the element of the list. So remember, I think we showed here in the console the .x. Remember that the walk functions have this argument .x that is important. So that refers to each element of the list. In this case, for example, the data. But then that element of the list also has a name, so we can refer to the name as .y. So .x is going to be the element that we care about, the data set itself, and .y is going to be the name of it. So what we want is to create 5 names, 5 paths, where each name in the list becomes part of the name of the path where the file will be saved. So that take this element, make a plot, and then save it with a name that contains the name of the element of the list. That was a mouthful. Let's see that in action. So I'm using, as usual, the function here. You already know how it works. Here, with a parameter that says output, what it's going to do is going to create a path that starts with output. Do we have such a path in my computer? Let's check. Yes, so there is this folder called output and already has some plots that I can now delete. So let's clean the folder called output. It's empty now. So now let's go back to our plot, our code, and here we are. So what we want to do now, there you go. Let me make this a little bigger, or probably smaller from here. What we want to do now is complete the path. For that, we need the help of glue. So glue is a really cool function that allows you to combine variables. So say that we have the variable .y and we store something like Brazil, right? So if I say glue, I like curly braces .y, what do you expect to happen here? I like Brazil. So where it saw this curly braces syntax, it replaced the thing with the value that the thing was storing, right? So we can mix literal strings with values, right? With variables. So that's really cool. So in here, what we can do is just refer to, so as you can see, we refer to the plots that are created in the previous step. So up to this step, we are creating a plot. We refer to the plot itself with .x, as I mentioned before, but then iwalk is also aware of another argument, .y. Remember, that is the name of the plot. So what's happening here is that we are going to create, to basically walk through the function through the list of plots and apply the function ggsave, which has two important arguments. The file name that comes from calling this snippet of code. So as we know, that will create a path to each of the elements of the list, right? A path that is appropriate for each of the elements of the list. And then it has second argument, ggsave has a second argument, apart from file name, that is called plot, and that is the plot itself. So iwalk will allow us to save at once all the plots that the previous step in the pipeline has made. So look at this. In 3 lines of code, we have split the dataset by country, mapped that to a plot, and then saved it on this. So let's run that. As you can see here at the bottom, this is saving images. And now if we go to our output folder, you can see how there is, I had removed those files before, but they are all here now. Let's look for Indonesia, there it is. So that is the list approach of iterating, in this case, over 2 elements in parallel, the name of the list and the object that the list contains, .x and .y. Great, so the final thing is to enjoy the output of our thing with the slider. So I'm gonna see what the plot looks like for the range. This time was born around 1980, 1980 to the latest point. I render that, and now we are ready for the takeaways. So let's see what those takeaways are, and with that we wrap the workshop. We have no time left. Takeaways for this last and final section. Vroom, actually it's mistyped here, is a shortcut for doing something that's like in path to many CSVs. Then you map that to the function read CSV, each element of the list of the path, each path mapped to read CSV. You get a list of data frames, and then you reduce those data frames by row binding one by one until you are left with no one and a single entire data frame. We learned how to nest in 2 ways. Nest by is a way that produces a rowwise data frame that then you can combine with mutate and with summarise using a syntax that is very succinct and allows you to solve this iteration problem, like for example applying LM models to many elements in your data all at once in a very succinct way. For that you will need also a cross, and you can also do the same thing like the list way with mutate and inside it calling map. And then you can also use summarise at the end to extract some of the parameters of the models that you care about. In our case, we show how to extract the R-squared value, and then we use that to produce a visualization. We learned about ggsmooth, which creates, actually I think we saw that before, ggsmooth, which creates linear models, and ggsave, which is a function that we hadn't covered by ggplot2. In terms of communication, we learned that the value passed to params could be a list, and we can use that list, for example, to create a little slider, which is a nice interface for some cases where we want our kind of stakeholders to use our report in a very kind of intuitive way. And finally, in terms of iteration, I didn't go review. I think we used that function before. It is very useful for lists. I encourage you to check it out. We call reduce, which is also an iteration task, but I just discussed it in import. And then I discussed this idea that walk is a friend of map, just dedicated to functions called for their side effects. And iwalk is a special flavor map to, really. So if a function that maps over the elements of a list and the names, and you refer to them as .x and .y respectively. So that brings us to the end of the workshop. I thank everyone for being here, and I'll be here for the questions if you have any, or just to say goodbye.
That was great, Mauro. Thanks a lot for your time. It was definitely much faster. So that's good that we had the opportunity to go through it again and dive into the things that are more interesting and important for us. But overall, it was great. Thank you. Thank you for taking the time and doing it.
Thank you, Daisy. Yeah, I predicted that it would be, I mean, the idea was that the workshop would be so that everyone would find something a little new and a little challenging, and at the same time something that they feel comfortable with. Also, there was no other way of kind of structuring the workshop that I could think of, because our range of expertise was very wide, from people who have never used R to people that use R every day. So yeah, but yeah, I really appreciate, Daisy, that you have shown so much interest and asked super cool questions that expose aspects of the lessons that either I had forgotten to include, or anyway, that kind of shows your interest. Thank you, Freddie. Thank you very much.
Yeah, thanks, Mauro. It was really great.
All right, I will say bye to everyone, and I will upload the recording soon. Ciao, ciao.
Awesome. Thank you. Bye bye.